Hey guys, this is the U-Substitution that we did in class. I'm just putting a video together for any of you that didn't make it, or I might have gone too fast and you wanted to take some more notes on it. So I just wanted to put it together real quick and put it up in our classroom. Again, U-Substitution is a way for us to integrate functions that we might not necessarily been able to integrate any other kind of way. And it's a way for us to simplify things that just makes it that much easier to integrate. So in this particular integration, we have this function here. It's a 15 over 2 square root of x minus 4 with respect to x. And so in class, what we realized was that there's the first step that we can do with this integration is that we can take this 15 over 2 and pull it right on out, right? So we can do 15 over 2, pull it out, and then we're left with 1 over the square root of x minus 4 dx. Okay. Now, the next thing that we can do at this point is set up a U-substitution, right? There's not much else we can do with this integration. And so at this point, it's time to do a U-substitution. The question becomes, what do we set U equal to? If you take too big of a chunk of U, you're not going to be able to find the derivative of U. And that's key to doing a U-substitution. When you set up a U-substitution, you have to set it up so that way you take care of all of the variables within the equation. And in this particular case, the best thing to do is to do what's inside of the radical. That's usually a good first step, is to take what's inside of the radical. And so in this case, you've got x minus 4. And what that would be in terms of our U du, we take the derivative of x minus 4, and so that leaves us with 1 dx. Okay, so now if we just carry this on through, what I'm going to do now is replace everywhere that I have over here for my u's and du's. So my u is x minus 4, and that's going to be this right here. And my dx, well, that actually is now, okay. Now, I'm just going to rewrite this integration to make it look a little bit friendlier. Now, the square root of u is just u to the 1/2. And 1 over that, well, that's just u to the negative 1/2 du. Okay. All I'm doing is, all I did was rewrite it so it just looked a little bit friendlier and a little bit easier to work with. Now remember, when we have a situation where we're taking an integral of, use a different, we have a situation where we're taking an integral of, let's say, a to the n dA. This is the same as a to the n plus 1 over n plus 1. Okay, so remember that that's going to come in handy here when we're doing this integration. And so what we've got here is 15 over 2. I don't want to forget that. And I've got u to the negative 1/2 plus 1 over negative 1/2 plus 1. Okay, so now we've integrated this function, and what we're left with is 15 over 2. U to the negative 1/2 plus 1, well, that's u to the 1/2. Right? And negative 1/2 plus 1, well, that's 1/2. Well, we've got a fraction under a fraction. Well, we can kind of flip it, reverse it, and pull it out in front. And so this is equal to 15 over 2 times 2 u to the 1/2. Well, we can still simplify this even further. 15 over 2 times 2, these two are going to cancel each other out. We're left with 15u to the 1/2. We're still not done yet, right? We got it pretty well simplified here. What we got to do is we've got to go back and replace our u back with what we had it originally. So u was x minus 4. So this is going to be 15x minus 4 to the 1/2. And then again, we cannot forget about that constant c. Okay. Now, like I did on the other video, I want to take us over to Delta Math real quick and just plug this equation in. So here's our original integration of 15 over 2 square root of x minus 4 with respect to x. And what we came up with was, we said 15 parentheses of x minus 4 raised to the 1/2 plus c. For sure, and there we go. Again, we've got inner function, derivatives, and everything is good to go. Okay, 15x minus 4 1/2 plus c.